Okay, today let's talk about Codeforces Education Round 171, Problem D. First part is description. We are given an array A and the length of it is n, and we will know a function S. There are two parameters L and R. It means the sum of AL plus 1 till AR. This is the definition of function S. Next, after that, we can get a array B from A. That means the B, the first elements of B, that will be S11. The second element will be one S12, and the next element will be 1 3 till S S1n. The next elements will be S22, S23 until S2n. Next elements will be S33, S34, S3n till SNN. This is the definition of array B. So after that, the problem will provide Q times query. For every query, it will provide L and R. We need to return the sum of I plus L until R BI. We need to return the sum of from BL plus 1, L plus 2 until M plus R. We need to return the sum of them. This is the description about this problem. Next part, let's talk about the solution. For this part, let's provide more details information about the array B. Actually, the limitation of length of A is 1000 millions. So the length of B will be 2n plus n multiply n plus 1. This is very huge. For the elements in array B, we can make it at this form. First elements S1, 1, second S1, 2, next will S1, 3, S1n. This is the first line of array B. Second thing we can make it as S22, S23, S2n, and the last section S33, S3n. Last will be Sn. This is another form of array B. We can make it at a very huge triangle. So for this problem, there are 3 steps to solve this problem in a very low time complexity. Actually, for every query, the problem will provide the L and R. We need to provide the value in a very low time complexity, maybe O(n), maybe O log n. This is O(n) will be the maximum time complexity we can accept it to solve this problem, to solve every query actually. So for every query, we have for every L and R, that means every query, we have 3 steps to solve this problem. First of all, steps. First of all, for every L and R, we need to find the position. We need to find the position of L and R in the big triangle. So the first thing is we need to find the position in triangle. That means the position means we need to know the vertical dimension and horizontal dimension. That means the L will located in which columns and which row in these triangles. This is the first thing we need to do. So the second thing, we need to get an internal intermediate array in the vertical dimension. That means vertical sum. Vertical, that means cumulative sum. That means we need to cumulative sum array in vertical dimension. After that, for example, after we calculate the cumulative sum array, this is a intermediate array. After we know the which line of L and R, we can calculate the sum of for example, this will be L and this will be R. This is the position of L and R. Of that, we can calculate the sum of this line. Sum. I mean, this is sum. We can get the sum of this value. So after that, the last thing we need to do is get the cumulative sum in a row. That means we need to get the sum of this value and this value. After we know the sum in the vertical cumulative sum, we need to sub the first line and subtract the second. Actually, we need to subtract the first part. Or we can calculate the sum of this part and add the cumulative this part. This is the problem. So there are 3 steps that can help us to solve every query. First of all is find the position of L and R. Second, we need to calculate. The cumulative sum in the vertical dimension. Last thing is we need to for every position we need to get the sum in the horizontal dimension. That means we need to process it, make the sum be a specific answer. So this is the third part we need to answer. Actually, this is an institution. That means the triangle is very large. We cannot calculate every element of B because the length of B is very large. So we need to, when we met this kinds of problem, we need to try to calculate some intermediate array that can help us to solve this problem in a lower time complexity. So in the next 3 parts, let's talk about the 3 things, how we can do this. So the first thing is get the position. Actually, we can, after we get the triangle, we will know the first line, the amount of elements in the first line will be n, next will n plus 1, n plus 2, until 2, 1. This is the amount for every row. After that, we can get a cumulative of this array. After that, for every L and R, we can use the lower bound function and find the position of L and R. For the lower bounds, we want what for if we have a given array, that means can see an amount. if we have an array and sorted array and a value, that means L, lower bound will return a value. The first one that is larger or equal L. So this is the definition of this value that will show this is which the index will be the value. The index of value will be the row of L. Yeah, after that we will know the position of, we will know the vertical dimension of L. After that, if we, it is also very easy, we will know the length of it. We can make it at amount, and we will use this variable in the next few minutes. So this is the first thing. That means we need to calculate a cumulative array that can help us, and the lower bound function that can help us to get the position of L or R. This is the first part of the problem. For the second part, how to calculate for the big, huge triangle, how to get the sum, cumulative sum. Let's provide more detail about this triangle. The first elements will be S1, 1. Second will be S1, 2. Third will be L1, 3. S1, N. For the first line, this is the first line. For the A1 elements, we use it n times. There is A1 for every element in the first line. That means for the sum of first line, we use A1 n times. That means A1 plus multiply n will be part of the sum. For A2, we know we used n minus 1. A3, we know we used n minus 2. For An, we know we used only one time. This is how we calculate the sum of first line. For the second line, it will be S2, 2, S2, 3, S2, 4, 4, S2, N. For the sum of A8, we will know there is no A1, so A2 will N plus 1 times. A3, N plus 2 times. An 1 times. 1 times. We will find the sum of second line will be the last n minus 1 elements of first line. So if we calculate the sum of second line after we add only one elements, that means A1, we will know the sum of first line. That is how we calculate the sum of every line. There is some special relationship between two continuously line, the sum of two continuously line. So we need to calculate the sum of line from the last line, that means last one to the first one, one by one. After that we will know the sum of every line. So after that we can calculate the cumulative sum of sum of every line. Calculate sum. So this is very important. After that, for every time we know the position of L and R, we can calculate the sum of this line in O1 time, because we know the calculative sum. This is only a calculative or prefix sum problem. This is very easy to solve. So for the last thing, we will know we need to calculate this part and this part. Actually, this part is equal the whole line subtract this part. So what we need to do is to calculate the sum of this part. After that, we can get the specific answer. That means sum of from L to R. So the next part, let's talk about how to calculate this part. For the third part, for a triangle L and R, let's make this length means amount. Let's take an example. It's easy to understand how to solve this problem. Let's make n plus 5 and amount plus 2, and this is the second line of in this triangle. It will be this line. The elements in this line will be S22, S23, S24, and S25. This is the second line. What we need to do is calculate the last two elements. We will know for the A5, it used 2 times. 1 times, actually, there is last word. So for the 4, we will know it used 2 times. For the A3, actually, there are, for this whole line, it used, the sum of the whole line use A3 3 times. But the first elements, that means this elements is not in the sum of the amount elements. So we don't need to use that. So for the sum of first elements in this array, it only used 2 times. 2 times. For the A2, it also used 2 times. So after that, we will know for the sum of this amount elements in this array, there are several parts. First part is the entry is the first 2, that means first elements. So they will be sum of an plus multiply 1 plus a multiply 2 plus 2 plus a minus 2 multiply 3 plus until an minus amount plus 1 multiply amount. That means we need to use this trend. The index of array A is decreasing and the amount is increasing. This is decreasing, this is increasing. There are amounts, these kinds of elements, so we need to sum of them. This is the first part. That means this is the first part. So for the second part is the last thing. The start of second part will be 2 because this is the second line. So first thing is line. That means this value will be 2 because this is the second line. That means multiply a line plus 1 This will be amount. So until n minus we need to know the amount of elements in this line. That means n plus amount line plus 1. So this is the amount of this line, and minus amount. Is there something wrong? Okay. A minus line minus amount. So we need to sum this and multiply times. What times we can write it? There will be amount because we need amount. This is how we calculate the sum of second part. The first thing is calculate this sum, and second thing is calculate the times we need to multiply. This is second part about how to calculate the sum of this interval. Okay, this is all solution about this problem. If you have any confusion, welcome to submit a comment. Okay. Last part, let's talk about complexity. Actually, for the time complexity, first thing we have Q times queries, so it will be Q. Second thing, for every query, we need to find the position. For the position part, we need to use the lower bound function, so it is log n. For the last two steps, we don't need extra consuming time, so the time complexity will be Q log n plus n log n. Actually, it will be because we use this thing because we use this thing in the re-prepare process. That means we need to when we calculate the maybe we don't need this. Maybe we don't need this. This is only on in the when we are calculate the intermediate array, we don't need too much time. So the time complexity will be max Q log n and n. This is time complexity. For the space complexity, we don't need the extra space. The only thing we need to store is or array or vector. So the space complexity will be On. Okay, this is all thing about this problem. Thanks for your watching. If you have any confusion, welcome to submit a comment. If you have any confusion, welcome to join my Discord channel.